Hello and welcome to LuckyMath. So why should you learn about exponential functions? Well, they turn up in finance, they turn up in different fields of science, for example biology, if you would like to describe the growth rate of some new species of bacteria, or maybe you're into physics and you would like to describe the radioactive decay. So you can almost not avoid exponential functions, and therefore I'm going to show you now how you can describe such a process mathematically as exponential growth or exponential decay. And for this we're going to look at any random quantity, and what we're interested in is the amount of that quantity to any moment in time t. So what we're really looking for is this function n of t, which describes the amount of our quantity n to any moment in time t. Let this be our time scale in units of seconds, and then what is always a given is the initial amount of our quantity. So the amount at t equals 0, and I just abbreviate this by n0. So at time 0 seconds we will have our initial amount n0. And now in this example, let's suppose that we have 3 times n0 at 4 seconds. And suppose this grows again by the factor 3 in the next 4 seconds, then we would have 3 squared times n0. And assume this will happen again, then we would have 3 cubed times n0. So what I did in each step was simply multiplying times 3. And this is what is called the growth factor A. So in this case the growth factor would be 3. So this is indeed an exponential growth because the exponents rise in every step we take. So first we have 3 to the power 0 times n0, then 3 to the power 1 times n0, and so on. And furthermore, the time needed to grow by such a factor 3 would be tau, and in this case it's simply 4 seconds. So this right here is tau, and this equals 4 seconds. And we get tau here again in this interval, and so on. And now what we really want to look for is, of course, this function right here. What is n of t? Because n of t would describe to any moment in time t how much of our quantity n we have. And there exists a general equation or formula which can do this for us, and it is the following. Namely, n of t is equal, and now I'm going to use black for the initial amount quantity, so is equal to n of t equals 0 times the growth factor a, so times a, and we take a to the power t divided by the time needed to grow by such a factor, which would be tau. And now let's just check at this specific example if this formula really works. So let's say that n0, so the initial amount of our quantity, would be 2. So these could be 2 bacteria, and we just describe, and we say that at each 4 seconds the bacteria will grow by a factor 3. I don't know if this is possible, I'm no biologist, but let's just do it. So then, if n0 equals 2, then this would just be equal to 3 to the power 0 times 2. This would be equal to 3 to the power 1 times 2. This would be 3 squared times 2. And this would be 3 cubed times 2. So now let me just do all in black. What we would get would be that n of t is equal to the initial amount 2 bacteria times the growth factor 3 to the power t divided by, and this would be 4 seconds, so divided by 4. And you also see that the units are right in this exponent because time is in seconds and also tau is in seconds, so they just cross out. Now let's check, is this really the equation we were looking for? And let's set in, for example, t equals 0. So what would be n of 0? And you know what should turn up would be 2. And what you see is that if we set this exponent equal to 0, this would just be 1. So we were left with 2 times 1, and this just equals 2. Perfect. Let's check some other value t. So for example, 8 seconds. And we would get n of 8 is equal to 2 times 3 to the power 8 divided by 4, which is equal to 2 times 3 to the power 2. Exactly. And this is just equal to 18. So this equation really does what we want. And you can be sure that you can always use this in order to solve any of such problems. Alright, so what we did so far was always exponential growth. So growth happens, exponential growth, always happens if your growth factor A is greater than 1. And then you will get a function n of t right here, and you can see it is indeed an exponential function because you have an exponent as an argument t. Then n of t is dependent on t. This would be the origin. And our function would look approximately like this, where it crosses the y-axis at the value n0, so at the initial amount. And so you have to be careful, these exponential functions here don't cross the y-axis at 1 because you have this additional factor n0 in front of your exponential function. Now, what is exponential decay? Well, the only difference to exponential growth is that the growth factor is less than 1 and greater than 0. So decay happens if A is in between 1 and 0. Why? Because then you would multiply in each step times the factor, for example, 1/2. And the quantity gets less and less as time goes by. So such a function would look approximately as follows. We again have n of t, then this has to be the time axis, and exponential decay would look approximately like this, where it also crosses the y-axis at the value n0, so at the initial amount quantity. So thanks for watching, and if you wish that my channel as well grows exponentially, then subscribe. See you soon again on Lucky Math.